Morning everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this video lecture series, I'm going to explain about the mobile network and the transport layer. So in this particular video, I'm going to explain about what is meant by transmission control protocol. So it is nothing but the supporting the mobility on a lower layers up to the network layer is not enough to provide mobility support for applications. So most applications rely on a transport layer such as the transmission control protocol or the user datagram protocol in the case of the internet. Two functions of this main transport layer in internet are the one is checksumming over the user data and another one is multiplexing or demultiplexing the data to and from the applications. So while the network layer addresses this host, the ports in the UDP or the TCP allows dedicated applications that to be addressed. So the traditional transmission control protocol, it is nothing but one of the core protocol, and it is mainly used for a IP suite, that is Internet Protocol Suite. So it is often referred to as a TCP or IP. So this TCP is reliable in order to deliver our data and incorporates the congestion control and the flow control mechanisms, which supports the internet popular application protocols like World Wide Web file transfer protocol and a secure shell. So in this IP suite, TCP is the intermediate layer between the internet layer and the application layer. So the major responsibilities of this TCP in an active session are it provide reliable transport of data. That is, it does not give any loss of data. So the next one is congestion control in the networks. It means it allows the degradation of the network performance. Next one is it controls the packet flow between the transmitter and the receiver that does not exceed the receiver's capacity. Then the next one is a TCP, which uses a number of mechanisms to achieve high performance and avoid congestion collapse where the network performance can fall by several orders of the magnitude. The various transmission control protocol mechanisms are it mainly used to improve the efficiency. So the particular mechanisms are, the first one is congestion control, the second one is slow start, the third one is a fast retransmit or a fast recovery, the third one is the implications of mobility. So now congestion control is nothing but it is mainly designed for fixed networks within the fixed end systems. So this congestion may appear from time to time even in carefully designed networks. The packet buffers of a router are filled and the router cannot forward the packets, which does not enough in order to get a higher capacity of the output link. So the dropped packet is last for the transmission and the receiver notices a gap in the packet stream. So the next one is a slow start. When compared to the congestion control, here the acknowledgement which we are getting from the control is being missed, and it is quite drastic because of this slow start TCPs. The behavior of this transmission control protocol shows after the detection of congestion is called a slow start. That is, it shows the detection of congestion. That is important here. While detecting the flow of control, that congestion control will be called it as a slow start. So the start size of the congestion window is one segment. So the sender sends one packet and waits for the another acknowledgement. So this is nothing but a flow of a slow start here. This scheme doubles the congestion window every time where the acknowledgement comes back. So where 1, 2, 4, 8, these are the packets where the client is being sent and the server is being acknowledged by the uh, device. So will be this process continuous for the every acknowledgement. Every acknowledgement we are giving the process, this cycle continues. So it is called as a round trip time, that is called RTT. This is called the exponential growth of the congestion window in the slow start mechanism. But double the congestion window, uh, but doubling the congestion window becomes too dangerous. So the exponential growth of the threshold is shown in this two particular graph. So the next one is fast retransmit or the fast re-recovery. Here the congestion threshold can be reduced because of two reasons. The first one is if the sender receives continuous acknowledgement for the same packet. So the next one is there is a gap between the packet stream, and that is not because of due to congestion but a simple packet loss due to a transmission error. So the sender can now retransmit the missing packets before the timer execution behavior is called as the fast retransmit. So this is how the TCP or IC works, where the diagram shows from the internet the same sender, application layer, transport layer, internet layer, and a network layer. This is being reversed in the receiver part. So in between that we are connecting with the internet. So the sender can continue with the current congestion window. This mechanism can improve the efficiency of the TCP dramatically. So the main disadvantage of this scheme is insufficient isolation of packet losses. The final one is implications of mobility. Here, the slow start mechanism in fixed network decreases the efficiency of TCP if used with the mobile receivers or the senders. Error rates on wireless links are orders of magnitude higher compared to fixed fiber or a copper links. So the mobility itself can cause the packet lag. So the assessment is how what is mean by TCP and what are the traditional TCP mechanisms and what is mean by fast retransmit. Thank you.